Welcome to Science is Stretching 3.0, the ongoing narrative since this paper was published in 2016. So if you look at more recent papers, this is the highlights of today, is that the dose matters. We really have to look at, when we're trying to make decisions, what are we measuring here? Is it acute effects? Is it chronic effects? How long do the effects last? So when there's an isometric contraction and the muscle doesn't shorten, it stays the same length, it's still trying to shorten. It's just some other force is keeping it from shortening. And the same thing with an eccentric contraction. You're still trying to shorten it, but some other force is taking over and making the muscle go longer. And then also explain the mechanism a little bit. And I think that should help you moving forward in deciding when to stretch and how to stretch and what kind of stretching. Imagine this was an extracellular matrix, right? And that you had some matrix breakdown. I'm going to talk more about matrix breakdown near the end, but you had some matrix breakdown. Do you think that might affect force transmission? This part is attached to the bone, and this part is the muscle. Well, tendons are generally stretchier at the muscle than they are mid-tendon or bone. So it depends, your stress strain curve is going to depend on where you are in the structure as well. And when these cell bodies enlarge, they become more active and they are more involved in the chemical soup, so to speak, the extracellular environment. And she does some really interesting stuff on inflammation, way beyond my interest level, but I think it's really profound research. Tendons are tensile structures. So when you go stretching to end range, like massive end range, like clasping my hands behind my back, or here going into deep hip flexion, deep forward bends, what happens is that tendon gets wrapped around the bone.